Okay, chapter 17, aqueous ionic equilibrium. It's a quote from Otto Witt. In the strictly scientific sense of the word, insolubility does not exist, and even those substances characterized by the most obstinate resistance to the solvent action of water may be properly designated as extraordinarily difficult of solution, not as insoluble. So you may know that antifreeze is dangerous to pets. Do you know why? Because it's cold. Well, I mean, obviously, just drinking random, automobile fluids is probably not a good idea. The problem with antifreeze is it has a sweet taste to it, because, if something tastes nasty, animals won't eat it, right? So no big deal. But ethylene glycol, an ingredient in antifreeze, has a sweet taste, and so the animal finds this stuff and then starts drinking it. Ethylene glycol is an alcohol. It's a form of an alcohol, and so the first symptoms of ethylene glycol poisoning resemble drunkenness. But then as your body metabolizes it, it turns into glycolic acid, which gets into your blood and changes the acidity of your blood. So your body really tightly monitors and regulates the pH of your blood, because that pH has a great deal of effect on different chemical reactions in your body. So the glycolic acid lowers the pH of the blood, and that causes death, pretty much. So your blood is within 7.36 and 7.42 in pH. It's a very narrow range. So this is pointer. This is a space filling model of ethylene glycol, and the formula underneath. And it's actually a dialcohol. It's got an OH. Well, you can look for yourself. It's got an OH at each end. Each of those are alcohol groups. Oh, it's going to be a great technology day. So how does your blood maintain its pH? It does so by the use of buffers. And we'll be learning a lot about buffers in this chapter. A buffer is a chemical system that resists pH changes by neutralizing added acid or added base. So in your blood, one of the important buffer systems involves carbonic acid and bicarbonate ion. So carbonic acid is an acid, obviously, and it can react with hydroxide ion to form hydrogen carbonate ion. So if there's too much hydroxide in your blood, the carbonic acid can neutralize it. The hydrogen carbonate ion can act as a base and neutralize any extra hydrogen ion that's present, reforming the carbonic acid. So that works great, unless you get too much acid or too much base getting pumped into your blood. So large quantities of glycolic acid overwhelm the capacity of the buffer system, causing the blood pH to drop to dangerous levels. So low blood pH is acidic, and that's known as acidosis. Diabetics need to be especially careful of this because this can happen to them. Acidosis is dangerous because it affects the equilibrium between hemoglobin and oxygen. Your body is very dependent on a very tight balance of lots of different equilibria. So hemoglobin carries oxygen, so it'll pick up the oxygen and to form the hemoglobin with the oxygen, and then it releases hydrogen ion. If there's excess hydrogen ion in your blood, if the pH is too low, that forces this equilibrium towards the left, and the hemoglobin will not carry the oxygen at a high enough rate. And so the result is you don't get enough oxygen, even though you're breathing and your blood's pumping around. hyperventilation, coma, and death. So what do you do if someone has consumed ethylene glycol or an animal has consumed it? One treatment is the administration of ethanol. Lots of vodka, basically. Any alcohol. Because your body and animal bodies preferentially metabolize the ethanol. So the ethanol will keep it busy and allow the ethylene glycol to pass through unmetabolized. And so alcohol is good for you, right?